Okay. All right. This is the I guess I should probably speak a little more clearer. All right. So this is the for finding functions and one-to-one functions with a graph. Basically, here let's first draw a graph, right? Okay. And so a 3x squared function would look something along the lines of this. You don't have to have an exact thing for finding out if it's a function or one-to-one function. So the way you find out if it's a function is you do the vertical line test. That means you draw a vertical line, and if anywhere in the graph where where the vertical line touches two things, like two lines, like let's say a function was like um, this. Okay, you see how when I do a vertical, actually, you know what? Let me do that with a different color. See how when I do a vertical line, it touches this orange line that we drew more than once? That means it's not a function. But in this case, with over here, it only touches the thing once. No, in no spot does it ever touch the thing. So that means that it is a function. So that's right. A equals yes. And then for one-to-one functions, let's find out over here. So let's redraw that. And then for the one-to-one function, we draw a horizontal line test. If the horizontal line, see how it meets it over here and here, it touches the line, the function more than once, that means it's not one-to-one. If it only touched it once, then that means it is one-to-one. I realize that the mic is a little too sensitive now. Hopefully it's better now. And so yes, that means that b equals no. Okay, now let's do y equals x plus 1. By the way, if you ever forget what I do a lot, like I don't remember all these things, how they look on the graph. So if you just plug into your calculator x plus 4, you just get the general shape. Because when finding functions, you don't need the actual numbers. So by the way, the plus 4 does mean that it means that it starts on the fourth line. But in case you ever forget, like what I do a lot is just plug into the calculator and then you get the general thing. So let's start with the vertical line test for finding out if it's a function. It is a function. It only touches it twice. So A equals yes. And then B, for a one-to-one function, it also only touches it once. Only ever touches the blue line once. So B equals yes. So it is a one-to-one function and it is a function. Okay. Now, y squared equals x squared plus y. Now you can't really plug this into a calculator, but what you can do is you have to square root both sides. So you get y equals plus minus x plus 1. Now, so it won't be a function because it will um um because it will it's not, you can't have a plus minus thing. I'm pretty sure. It just doesn't work like that. It'll you can plug it into your calculator if you want. Um oh, you know what? Should definitely do that. For next video, I will put on I'll have an on-screen calculator. That's great. Um and basically you can see that it won't work. You can't have a plus minus thing, I'm pretty sure. Okay, y equals 5 over here. Okay, so now let's draw 5 because that means it's a straight line, horizontal. X is vertical, y equals a number is horizontal. And it starts in the fifth line. So if it's a function, we can try to find by doing this. So it is a function because it only touches the black line once. So A equals yes. And then B equals, let's see if it touches it more than once. Yes, because the whole line is going horizontal. So it's not a one-to-one function. By the way, a one-to-one function means that so means that different x values can equal the same number, right? But x equals 1 will not work. We can see why. X equals 5, I mean, because it's a vertical line going down, and when you do the vertical line test, it'll go down with it. So there's more than one, it'll touch more than one point on the graph. So if a equals no, then it's definitely not a one-to-one function. You don't even have to try to find it out, because a one-to-one function is established on the fact that it's already a function. All right, now let's go to here. And let's see, how long do I have? Okay, great. Okay. Determine whether the following sets of points can belong to a relation or function and or a one-to-one function. Okay, so see how there are so the way to find it out with points is that if there's an x that repeats, so the x, it goes x and y. See how the x here is 0 and there's another 0 here? But because they land on the same y, which is 1, it's still a relation. A relation is just means it just means that a relation just means that it's a connection between sets of information. And yeah, so like it means that it has one output and one input. Yeah. So basically, because these both have a 1, it's still a relation. And because there isn't anything else that really repeats, it isn't. And also, sorry, a relation means that if let's say 8 and let's say 3, but also -1 has a 3 as a y, then it's not a relation. But it's still a function, it's just not a relation. I think. Could be wrong. I don't know. So A is yes. Now let's look for see if it's a function. Of course it's a function. We already figured that out. Since there's since 0 and 0, since 0 has a 1 over the y here, if this had a 0 and a 2, then it would not be a function, because that just doesn't make sense. An x can't equal two different y's. It has to be yeah. So A equals yes. B equals yes. And then C, if it's a one-to-one function, it is a one-to-one function. Because again, it doesn't repeat. It doesn't have like it doesn't have when it goes here, like when it goes so see how it's -1, 0, and 8 if we put it in order for all the x's. Since -1 is 9, 0 is 1, and 8 is 3. How can it be a yeah, because yes, because the y's don't repeat. Okay, so now let's go into this one. It is a relation because yeah, it always has it stick to its points. It has yeah. Now B, it is a function because two x's don't equal the same number. No, sorry, I did that wrong. two x's meaning two of the same x. So let's say x, x. If 2 had 1 and 2 had 2, it wouldn't be a function because you can't have an x equal two different numbers, two different y's, to have two different outcomes. That can't happen. So it is a function because it doesn't have that case. So yes, but now if it's a one-to-one function, you see how the 5 repeats over here in the y for two different x's, how it's a 9 and a 2. That means it's not a one-to-one. Alright, so now okay, and again, please text if you would like me to go over C and D. Okay, now number 16, determine whether A, the following graphs are functions, B, the inverses of the function of the following graphs are functions, or C, the graphs are one-to-one functions. Okay, so let's first see if they're functions. Let's do the vertical line test. Vertical line, great, it works because it doesn't repeat the x. It doesn't follow two. It doesn't connect to two lines and things. See how there's only one connecting point. So yeah, so that means A is yes. And now let's find out for B, which is the inverses of the following functions when the graphs are one-to-one functions. So let's see. This is the inverse. No, sorry. Here, so the inverse would be like this. So I'm not super sure. I'm gonna look this up because I'm not sure why she puts in as it is not a function, the inverse, because isn't the inverse just this flipped over? Let's see. Why wouldn't the inverse of a graph function be a function? We're going to find this out together. When the graph is not one-to-one, that means which graph radically inverse means flipping the function across the diagonal line. Why? Oh, okay. I was looking at this the wrong way. When I thought the inverse was just a complete flipping over. That's a reflection, it's called. But no, it is not. It is when it's flipped over the diagonal side, so the y side. So it'd be like this, which isn't a function because when doing the vertical line test, you see how it has two things on the line. It is not a function, so no. And then C is no because on the normal graph, because when you do the horizontal test, it touches the line in more than one place. Okay, and then we can also figure out here. This is the inverse, let's say, or it could be the other way. Doesn't really matter. Okay, following graph is not a function because when we do the vertical line test, no. Okay, now B. If the inverse is a function, it is. Because, look at this. This is the inverse would be like something like that. I don't know. I can't draw it. But it would be if you find the inverse. Because it'd be on the y's. So since the y's like that, yeah, because it'd be something like this, which is a function. Okay, and then C, the graph is a one-to-one function. If they are not, it is not, because it's not. If it's not a function, then it's not a one-to-one function. Great. Determine whether the following tables of x and y values A represent a relation, B represent a function, or C represent a one-to-one function. So let's see. Let's first write this out. B, C, A, B, C, A, B, C. Okay. Now, you see how, so it is a relation because each of their things, yeah, it's like a thing that follows in order. Here, let me see if I can find a better way to explain this. So every function is a relation. Okay, so if it's a function, it's a relation. It's as simple as that. So first let's find out if it's a function. Let's see. 0, 1, 1 to 2. It doesn't ever repeat itself where it has x. If it had, let's say, let's draw a little table here. Oops. Awesome. And so let's say x had 1 and a 1 here, and it had two different outputs as the y, then it would not be a function. But since it's a function, this is yes, and this is automatically yes. Okay, let's see if it's a one-to-one function. See how the y's repeat themselves? So it is not. Okay, let's skip on down to this one. So let's first see if it's a function. 0, 4, 5, 6, 4. 4 and 4 is negative 1 on each side, so it is a function. And then it's a relation. Alright, and then let's see here. See for a one-to-one function. 0, 4, 5, 6. See how it doesn't ever repeat itself? The y, it is a one-to-one function. Okay. Now we can see over here. A, B, C. We're gonna just skip on down to here also. A, B, C. Okay, 1, 2, 3, 4. 1, 2, 3, 4. So, this is tricky now, because this is where it would be a relation, but not a function. Because each set of numbers is like connected to their own thing. So it is a relation, but it is not a function because you see how this x has two outputs leading to different results. That means it is not a function, and then it would automatically not be a one-to-one function. So let's see here. This is also another tricky thing where it is a relation, but not a function. Not a function. Let me see if I can find an even better way to tell if something is relation if it's not a function. Okay, so basically if there's any pairing with an input and an output, then it's a relation. Since this thing here isn't paired with anything, it is not a relation. Okay, great. 18, 19. You can use the blank to visually determine this is what we went over. You can use the vertical line test. line test, or you can use the horizontal line test to see if it's a one-to-one function. Now 20, what's the difference between a function and a relation? So a relation is just, I'm not going to write this down because I don't feel like it. So basically a relation is just a relationship with, we just found that out. A relation is just a thing, a relationship between between the x and the y. So if every x has a y, then it's a relation. If not, then no. A function is when the each x has only one output. If an x has two outputs, then it's not a function. A function and a one-to-one function. So a function, a one-to-one function, has only one y, like only one output for each x. Like, you can't have 2, 5 and a 3, 5, because that would not be one-to-one function because it has two y's, like two outputs for two different numbers. The same output for two different numbers or more different numbers. Okay, is y equals 3x plus 1? Why or not? So y equals 3x plus 1, that's like a thing like this. Let me draw with different colors. So it's something like that. And it is a function because when you put down the vertical line test, it only has one spot on the thing. And then x plus y squared. So the way that when you'd figure this out, because yeah, it's squared, you'd have to have a square root as the answer. And when anything is a square root as the answer, it's always plus minus. And whenever there's a plus minus, it's not a function. It just wouldn't work. Yes, we finished semester 1. Alright, I don't know why I'm doing that. It's weird. Okay, okay. Well, that was the longest video yet.